Section 3.2, solving systems algebraically. This is review from Algebra 1. We also did just a smidge of this in geometry. So to solve linear systems algebraically, these would be graphs of lines. If we look at the ones from yesterday, we could solve each one of these for y. We could graph each one and get the answer that way, or we can just solve by substitution. So what you're going to do is you're going to look through the variables. You're going to find the simplest one to solve by itself. So when I look at these, I have a 3x, a 4y, a 2x, and a y. So when you look at this one, which one is the simplest one? And just, I'm looking at the variables only. Just the y, right? The one that has a 1 with it. If there is one, pick one like that. So what I'm going to do is I'm going to solve this second equation for y. Could be.
Yeah, in our
Okay, let me put that in there. Thank you. That will make a big difference, I'm sure. Okay, so I'm going to solve the second one for y. So it's y equals negative 2x plus 10. You could solve any of the equations for any of the variables. However, when you look at solving, for instance, the first equation for x, you would have to subtract 4y and divide by 3. You might end up with some fractions there. It's doable, but it's much harder than if you look for the one that's the simplest to do. So what we're going to do is, since we now kind of know what y is, it's negative 2x plus 10, we're going to go to the other equation and plug it in for that variable. So that's going to go in for that pink circled y. Here's what it looks like. 3x plus 4 times my negative 2x plus 10. So I'm substituting it in there, equals 12. Everything else stays exactly the same. This negative 2x plus 10 goes in for the y. Now, if you plug it into the wrong equation, everything will disappear. It'll be like 0x equals 0, and that won't make sense either. Okay, so now we're going to do a bunch of simplifying, and we're going to solve for x. So distributive property gives you minus 8x plus 40 equals 12. Negative 5x plus 40 equals 12. And then I will subtract 40 from both sides. Yep, that's what I was thinking. And then I don't think that's right. I think, is the answer like a regular number? Oh, it is a decimal? Okay. So x equals 28 over 5. Only take this to a decimal if it's an exact decimal, like you know exactly the number of decimal places that it is. So 28 divided by 5 is 5.6. You can use that. I'm going to say do not round them, especially if you have to plug them into something else, because the rounding will cause it to be incorrect. Do not round. Here. So we'll go back and substitute it back in to find out what the y value is that goes with it. So you can either use a 28 over 5. This would be the same as 5 3/5 or 5.6. You can use any of those. You're going to plug them into this equation. So negative 2 times 5.6 plus 10. $11.12. Is that right?
negative 1.2.
Okay, hold on. Oh, yep, I put a 0.2 instead of a negative. Just a minute here. Negative 2 times 5.6 plus 10. There we go. If that were a fraction, it would be negative 6 over 5. You could also go negative 1 1/5. That works. Put it into an ordered pair when you're done. Now, unlike the ones yesterday, obviously you might get some fractional numbers. If you're not sure, what can you do? Plug them back in and check it out. So pick one of the equations, plug both numbers in, and see if it equals 10, for instance. So if I checked it, and of course you don't have to show this, you would just be doing this kind of on your own. So let's see if I have enough room. I'll go right here. 2 times 5.6 minus 1.2 equals 10. So I'm keeping everything on the same side that it's on. 2 times 5.6 minus 1.2. Oops, I did plus instead. And it checks out. So if you're wondering if you get something really strange, you can always check it out. It's not required, but you can check it. So don't add things and subtract things when you're checking though. Keep everything on the same side. So that checks. Everybody remember how to do that? I like elimination better, but I think you guys kind of like substitution better, I think. So when you're scanning these variables, I have a 1x, a 3y, a negative 2x, a negative 4y. What should we do? X on the top one. So we're going to solve this first one for x. So x equals negative 3y plus 5. You can also have the term switched around. 5 minus 3y works. So where do we plug that into? X on the second one. So whichever one you solve, you got to put it in the other one. This part right here will go in for that x. So negative 2 times negative 3y plus 5 minus 4y equals negative 5. When you plug it in, you're going to know if you have it in the right place because the variables that are there should now match. If you put it in the wrong place, you're still going to have opposite variables or everything will disappear. So distributive property gives you 6y minus 10 minus 4y equals negative 5. I'm going to put like terms together first. And then what do? Add 10. And then divide by 2. Now 5 divided by 2 is the same as 2.5. Can I keep it like that? Yes. It's a decimal that ends, so it is okay. And then we're going to substitute it back into any of the equations, but what's the easiest one? This one that you have already solved for your variable. You can plug them in anywhere, like I said, but then you have some things to do. If you use the one that you've found, that's the easiest place to put it. So negative 3 times 2.5 plus 5. What's that, negative 2.5? And of course we can check it out. Negative 2.5 plus 3 times 2.5 equals 5. Five does equal 5. Okay, and again, you don't have to show it, but you can check it if you want to. Especially if you get decimals. A lot of times when they're doing these, if you're graphing, they're going to give you nice numbers to graph most of the time. But here, evidently, it looks like they're going to give you some not so nice answers. Okay, a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are shown in the advertisement. What's the cost of each lesson and the one-time fee for materials? So when you're looking at this one, we are looking at 6 lessons for $300, 12 lessons for $480. I think they gave a little ad on this one, so I'm going to open my book and check it out. I think that information I took from the ad, but I don't think there was anything like hidden in there. Look at page 143. It's like piano lessons. It's purple, has piano keys on there. It basically tells you how much these are. What we're going to do is figure out the price for them. And we're going to have two equations, and then we'll solve them for the missing variables. So 6 lessons. We have the total, but we don't know how much each lesson is. So when you're looking at this, now I'm mixing up my pens here. This one would be 6 times the cost per lesson. Plus the one-time fee. Did it say what that was again? Okay, it's already included. So plus one-time fee, I'm just going to write kind of what we're looking at, equals 300. Now, would the other one look kind of similar? Right? Yeah. Okay, we just don't know what that one-time fee is. So the other one would be 12 times the cost of a lesson. And let's make this a variable instead. That will make it a little simpler. So 6 times lessons plus fee, we'll go F equals 300. And then for the other one, it's going to be 12 times the price per lesson plus that fee equals 480. Okay, so we're talking about two different things. How much is the one-time fee? How much is the cost per lesson? And we could solve these together. Now, what would be the letter that you would want to solve for on this one? F. Would it matter which one? No. When you're looking at it, you have a 6L, a 12L, a 1F, and a 1F. So it wouldn't matter which one that you solve for. I'm just going to go with the first one. F is equal to 300 minus 6L. This right here would go in for the second F. Do you need that in parentheses? You don't really need it in parentheses because it's just going it in for a 1F. So I'm going to put like terms together. And then subtract 300. And then divide by 6. So every lesson is $30. And we will have to plug it back in to find out what that one-time fee is. So 300 minus 180, what is that, 120? So very first lesson, you have to pay $120 plus $30 for the lesson. Every lesson after that is then $30. So $30 and $120. Sorry. The hardest thing there is trying to decide where your variables go. But remember, if it's two equations, they're both going to have the same letter for one of the items. They're both going to have the same letter for the other one. You won't have like 4 different ones. Decide what your variables are. You can use X's and Y's. If you do, though, define them. Like here, L for lessons makes sense. X for lessons wouldn't unless you said let X equals lessons. Okay, so define the variables if you don't do something very obvious. Okay. Let's just set up the equations for got it number 2 because I think you guys can probably do the solving part on your own. So an online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. What's the cost of each download and the registration fee? So is this one kind of similar to the last one? It is. So let's go D equals downloads. R equals registration. Which one do you only pay once? The registration. So we're going to do 15 downloads. So that would be 15D or capital D, whatever. Plus registration equals 1975. Is that right? And what would the other one look like? Yep. And then we would solve them the same as the other. So figure out which one do you only pay once. The other one would be a product or multiply. Okay, then we get to elimination. So this is the one that I like better because it seems to not take quite as long to me. What you want to do is you want to look at the variables, look at them in columns. So you're looking at the x's together, you're looking at the y's together. Elimination is just that. Which column would be easiest to eliminate the variable from, the x's or the y's? The x's, because they're already the same number, they're the same 4, and they're opposite signs already. So we're looking at eliminating these, and we don't have to do anything to them to get them to be out of there. So we're going to add them just like they are. So it eliminates that whole x column, and you're going to go 2y plus 3y is 5y, and 9 plus 16 would be 25. Then I divide by 5, and I get y equals 5. That part right there is really the only part that's elimination. The other part is back to substitution, so you can plug it into whichever equation that you want to figure out what x goes with it. So I'm going to just go with the first one because the numbers are smaller. I'm going to just say substitute back in. So 4x plus 2 times 5 equals 9. 4x plus 10 equals 9. 4x equals negative 1. Is it negative 1/4? Yep. Okay. Thank you. And again, we could check these too. So when I was wondering, I don't know if that should be a decimal or not, we could check it. You don't have to, but you can. So here, I'll say check. 4 times negative 0.25 plus 2 times 5 should equal 9. Well, 4 times negative 0.25 is negative 1, right? And 9 would equal 9. Okay, so again, on the checks, you don't switch sides with anything. You just keep everything on the same side that it's on, and then solve from there. Okay, let's do this one. Yep.
Can I move over there?
Yep. Yep, absolutely. You can move forward if you need to, whatever. You kind of are way back there. In the next one, which column would be easiest to get rid of? The 8s. And I'm kind of hoping they gave us one where they didn't do that already. But on this one, notice how these are opposite signs and the same number already. So I'm going to add. So I get 3x equals 12. X equals 4. And then I substitute it back into either equation. Negative 2 times 4 plus 8y equals negative 8. I'm going to add 8, and y equals 0. So 0, or 4, 0. X goes first, y goes second. And then you could check it. If I plug in a 4, I get negative 8 plus 0 equals negative 8. So that does work. And I substituted in, and I didn't even write anything down. So what do you like better, substitution or elimination?
Elimination.
I like elimination just because it just seems faster to me. You still have to do part of it as substitution, but you don't have to do all that variable stuff where you're trying to get the variable as a 1, especially if it's not given like that. If there's one that's a 1 already, I definitely would go substitution. But if there isn't, this way I think is definitely faster. So what do you do when all the numbers are different? Okay, which I was hoping they would do one like this. So when you look at the columns, I have a 2x and a 3x. They're not the same. They're not the opposite signs either. And then you have a 7y and a 5y. They're not the same and they're not opposite signs either. So I usually pick the ones that are smaller numbers, but that's just personal preference. So I'm looking at what can I get those numbers to be the same. Easiest thing is to multiply them. So if I make them a 6, they would both be 6s, right? And then you could subtract them. So what would I need to multiply that first equation times to make that a 6? Okay, so you're going to go that one a 3. Also, I need opposite signs, don't I? So the second one I'm going to do times a negative number, negative 2. And if I do one with a positive, one with a negative, the signs will be opposite. So here's what I get, and you have to do the whole entire equation. 6x plus 21y equals 12. And then I get negative 6x minus 10y equals 10. Now when I'm looking at it, my x column is the same now, so it will cancel. That's what we were looking to cancel. And I get 11y equals 22. Divide by 11, and y is 2. Where do I plug it in? Does it matter which one? No. Do either one. I'm just going to put a little note. Substitute back in either equation. I picked the one that looks simpler, but sometimes there isn't one. So 2x plus 7 times 2 equals 4. Subtract 14. X equals negative 5. And you can check it if you want to. Most of the time, if you get regular numbers, you're probably okay, but you might as well check it. So we get 2 times negative 5 would be negative 10. 7 times 2 would be 14. And then 4 equals 4 if I substitute back into that one. Yep.
So when you do like the first step, will you always be adding it?
Yes, I always do the subtraction with the second one if I can, but it doesn't always work that way. But I always add them. Make one a positive number, the other a negative number, and you'll always be adding. Yep. And I think that might be it. Nope, there are a couple more. Do you guys want to practice an elimination one? Let's just do one of them. Which one? Second one? Let's do the second one. Let's go elimination, not substitution. So if you had a choice, would you eliminate or substitute on this one? Probably substitute with the 1y, but let's practice elimination. Okay, so let's just do elimination on B. You can just practice on your own paper. Now, is it going to matter like if I choose the x's and you guys choose the y's?
No.
No. You would just find the opposite variable that I have. So go ahead and try this one, and then I will solve it. And I'll try to do the opposite of what you are probably going to do, just to show you that you do get the same answer. Okay, which column are you guys getting rid of? X's? Okay, so I'm going to do the Y's just to show you that it does still work. So if I add them, what does that mean? Is that what you got?
No solution.
Okay. When you're looking at it, if you get a 0 equals 0, basically, which is kind of what we have, right? Everything is gone from the left, everything is gone from the right. Look at your problem 5 on page 145. Basically, they are multiples of the same equation. So when you multiply this first one times 3, you would get exactly the same thing as the second one is. Do you remember yesterday when we did the graphing method? And when you graphed one of the equations, the second one goes right over top of it and you had all real answers? That's kind of what this is. So when you look at it, if every single thing cancels out and you get 0, this one is an... all real numbers, I think is what they put. Or when you're looking at it, you could, if you had to pick the kind of solution it was, you'd say dependent. This would also be infinite solutions if you wanted to put infinite. Whoops, just spell it right, I guess. So since we got a weird number there, let's look at the other one just to make sure. I want to go with the x's this time. So I'm going to multiply the first one times 2. So I get negative 2x plus 2y equals negative 4. And 2x minus 2y equals 0. I'm going to add them together. When is 0 equal to negative 4? Never. So notice how they look different. On the first one, everything canceled on the left, but I still had a number on the right. That's not possible. On the second one, everything canceled on the left, and I didn't have anything on the right. So 0 equals 0. That just means it overlaps itself. So this one is a no solution equation. And which one of those had a no solution? Those were lines that had parallel slopes. If you solve these for y, they would have parallel slopes. So I'm just going to put parallel after it just so you can kind of picture it in your head. They never cross, and those are, what were they called yesterday? Inconsistent. So sometimes you do get some strange answers, just so you kind of know what to do with them when you get them. So 146, if you didn't finish the graphing ones from yesterday or forgot graph paper, you can grab some because I put some more in there. There should be no graphing today. We're just looking at substitution and elimination. Be ready for a quiz on Thursday. The table stuff that we did yesterday is probably not going to be on there. It'll be more focused on the graphing and consistent, dependent, and inconsistent equations. And then today, substitution and elimination so far. So if you understood the graphing and what we did today, you should be good to go so far. We'll learn one more thing tomorrow and then take a quiz on Thursday.